Okay, so in order to have an action potential in the heart, we have two different types of cells, and those are going to be contractile and pacemaker cells. In order to reach an action potential, we have a bunch of different channels. We have potassium channels, sodium channels, and calcium channels. And then there's a whole bunch of different potassium channels. So we'll go ahead and draw it out. So the heart's action potential, the heart is a bit more negative than normal cells, and we're normally around -90 at resting membrane potential. So there's also 5 phases, 0 through 4, of an action potential in the heart. So 4 is going to be our resting membrane potential. And then the next phase is phase 0, and that's going to be the depolarizing phase, where we go all the way up to positive 20 millivolts. I forgot to mention, in phase 4 we have leaky potassium channels open, and that helps us maintain resting membrane potential. When we go into phase 0, we have sodium channels open, which causes a really rapid depolarization of the cell. And again, we reach positive 20 millivolts, and we kind of do this. Well, I guess we reach phase 1 first. And phase 1 is rapid repolarization. That's where our transient potassium channels, our ETO channels, are going to open. And that's going to allow us to repolarize pretty quickly, but then we reach a plateau, and this is phase 2. And in this phase we have calcium channels, we have potassium channels, ultra rapid potassium channels that open, we have rapid potassium channels that open, and then we have slow potassium channels that open. And so the calcium is kind of what keeps us in this plateau, and as these potassium channels open, we're actually going to be able to get out of this plateau, drop back down, and enter phase 3, where our leaky potassium channels reopen, and then these channels actually slowly close as we're in phase 3, which is another repolarization phase. And then we go right back into phase 4, where again, we just have our leaky potassium channels open, keeping us at resting membrane potential, -90 millivolts. So we'll also talk about the ECG. So the ECG has five different waves. That's going to be the PQ, RS, and T waves. And so we'll start by drawing out what's happening with P waves. So we have heart, we have our SA node, and our AV node. We'll draw our different chambers. And so we also have a negative electrode up here and a positive electrode down here, and that helps us get our ECG. And so That's what the P wave looks like. And that's happening because we have an electrical pulse going from the SA to the AV node, and our both atrium are depolarizing. That helps create our P wave. Then we have our QRS wave. And so we'll draw some ventricle walls here. And the QR and S waves are generated when the AV node transmits the electrical signals through the Purkinje fibers down here and causes the ventricles to depolarize and pump blood through the rest of the body. So our Q wave is just the initial depolarization up here. R wave is going to be generated when most of the electrical signals travels through the Purkinje fibers. And then our S wave is just the last depolarization of the ventricles of the wall. And then our T wave is generated when we repolarize our ventricles. So we'll just take away all this. And we repolarize back up this way. And that's how our ECG waves are created.